Right, how's it going? I apologise for the disheveled look. I know I'm not looking too flash, but I digress. Let's talk about my workshop. I have myself a CNC plasma cutter, fantastic at doing sheet work, but I have nothing to post-process, and I know in the upcoming future I'm going to need to do a bunch of folding. So I need to build myself a brake press. So let's get cracking. Right, this is the design I come up with. This is where your bench top is. That's your workbench, and that's where the sheet of steel will be bent against this die here, which is just square box section, and then you'll have some handles that come off it, just so you can lift it up. Now my two main concerns is the rigidity of this top plate that clamps onto the steel, as well as the hinges. And so let's cut those hinges out of 8mm thick steel. Right, got the bits off the plasma cutter. Pretty happy with how they cut out. Some of them didn't cut out perfectly square, and so just need a bit of a tickle with the grinder just to square them up again. You do want to actually go all the way through. The reason you want to do that is because it's actually tapered, so you work your way up through the threads, going from very small cuts to large cuts. And if you don't go all the way through like I've just done, then when you put your bolt through, it won't go all the way through because you haven't actually cut the threads completely. Now what's something really worth noting is the pivot point needs to be just inside this radius. I've gone for 2mm in and 2mm down. Now the reason that is when you pull up this square box section to create the form, you want it slowly moving away from the stationary part. Now that's just to create like a radius, so as you start the bend it's tight and then it smoothens out and widens. Right, here's the assembly of what I'm doing. We've got your handle, which will actually be two handles just to spread the load and stop twisting. We've got our hinges that will be mounted to the outside of the box section. This is a 1260 wide, where a half sheet of Corten is around 1240-ish. So this will give me a half sheet capabilities, which is fantastic. I'm still a little bit worried about twisting, as well as the rigidity of the angle section here. So we'll see how we go there, and then yeah, develop it from there. Right, let's measure this up and cut it out. Right, we're up to on the top section now. We've got the bit of angle in the flat plate and a bit of copper in the clamp. This is just to hold them together and make sure that it's flat and flush, so when you do clamp onto the steel it doesn't mark it, as well as it distributes the force evenly. Right, I have a confession. It's welded up and it is bananaed. Both up like that, as you can see, like that, as well as down the face here. Now both of them are very important edges and they do need to both be straight or square, so they need to be addressed. Right, it's been a while. About 30 minutes in I realised that my magnetic level or flat edge has been picking up bits of metal and was definitely not a flat edge, straight edge. So after finding out that, I then had to go back and fix what I'd done. I am shocked. That's fantastic. I just took it slow and easy, and I've got a straight edge. Oh, it's quite warm. Just put that back. Right, perfect. It's straight. Right, we now need to attach the nubs to this top section here. Now, I was going to originally cut out a V from the nub, but you're going to lose so much of the actual nub itself that it's not going to be structurally sound. So what I'm going to do is cut out the section on the angle here and then insert these down and then get a nice seam weld around these. And now hopefully that'll distribute the force evenly through the whole thing while not being getting mashed by the bolt every time you tension it. Right, let's give this a whirl. hey. Right, we're now wearing the nubs on. We want to keep them nice and square. So I've got myself a square, and I'll tack it on lightly and just check that it is at least square and plumb to itself, and then I'll seam it up nicely. Right, now that we've got the nubs all on, we now need to drill all the way through, so the bolt can go all the way through and then into the bottom plate. Now with this, I've got the nut and I've drilled a hole all the way through. This just gives us a little bit more adjustment so the bolt can go through another 5 mils. So we get a good thread bite when we tighten it down. Right, let's weld these on. Right, what we're doing now is welding in the end caps. I put a big chamfer on there just so the weld gets nice and deep. These need to be really strong and transfer the load evenly to the tube here, because this is where the hinges will be welded onto. Right, quick tip, if you're doing tack welds, do 3 and do them on the corners. It's just a good practice. Right, we need to grind this flat now. Now I'm pretty confident that this end plate here is actually square to the tube. So what I'll do is I'll come in with the grinder, try to keep the grinder as square to the tube as possible, and just come in and face it just until we start grinding away the blanking plate. Right, so we're just welding up the support bar for the bottom plate. Now, I'm only going to weld on the outside just because the inside's what catches on the edge of the bench, and if it's got welds there then they're not going to sit properly and it's just not going to sit flat, and so there's no point doing what we're doing. A whole bunch of very average welds. Right, pretty much doing the same thing, but this is for the box section that you lift up with the handle. Right, we've got everything lined up where we want. We now need to weld the hinges up together, so I've got them clamped with the little insert in between. It's the same width as the middle part of the hinge, just so then it can still freely move, but it's still got no slop, at least I hope. Fantastic! Yes! Right, I'll just seam this up and then we can start looking at the next job. Right, so what we're up to now is grinding the edges here. So I've ground them back and filled it up with weld because I went through the layer. Now when I'm grinding this back, there's no such thing as too much safety gear, remember? Yes! Right, what we're doing now is making the handles. So I'm just going to use solid 20mm bar. It's the strongest thing I've got, I guess. I could use 10mm solid, but that's not going to work. And I've got some extremely expensive line pipe, but it's also stainless, so I'll use what I've got. This is going to be very heavy, that's okay. So I've got my 20mm holes, which are perfectly 20mm, because obviously this doesn't fit in here, unfortunately. So I'll address that problem when I come to it. Oh, nice. Got oil everywhere. And then I'll tack that up, and then I'll get the other one lined up just the same. Once they're tacked, I can just readjust them and stuff so they're even. Oh! I should have just left it, really, shouldn't I? Oh well. Now I've got some holes on each side that I drilled through before, just so now I can plug weld them. So we're now transferring the load from not just one face of the box but both sides. I just think that will just give us a bit more strength, and it will reduce a bit of torsion. And Perfect. Right, you can see what we're doing here. We're adding some support like this. Now the higher that this triangle is, the more the force is going to be transferred through the rods and be stronger. So this is actually quite a aggressive angle. So aggressive? Yeah, aggressive. So this won't actually be transferring a whole heap of force, but the whole thing is already massive and heavy. So I'm just trying to reduce my footprint now. So now we're welding the handles on. Now I am tempted to weld a nut on top here, so then you can use your impact gun, so it's just nice and fast. Right, we're on the final touches. We've got these support bars, which will just give us an extra bit of oomph when we bolt it to the table. It's just further away from the leverage point, as well as we need to finish welding the nuts on. Now I can't MIG them because it protrudes too much, so I'm just going to have to TIG them. Right, let's crack on. Excuse the slug. Right, just finished it up now. Let's mount to the bench and do our first test run. Right, first test was fantastic. Just got a bit of grease everywhere. Look at that. We're a uniform bend, I'd say. It's about 15 degrees, but that's alright. Bit of wear marking on the face. I think if we added just a bit of grease where it wears, I think you wouldn't have that. Very big radius, but this is 2.5mm stainless. Yeah, right, let's try something a little bit bigger. Eh? Alright, I can say that did not work as planned. Ugh. Well, I guess it doesn't work when there's a massive hole there. Learning from our mistakes here, we should have actually had this section clamped into the chuck, we should have this bit clamped in. Unfortunately, I couldn't get it in because of my bench depth, but I didn't think that'd be an issue, but obviously it was. Let's try a large piece of stainless. Alright, that looks good. Gotta say, I'm regretting putting grease on everything, at all the wear points, because now my hands are so slippery. Look at that. So we've got, as you can see, we've got a little bit of wear marking, a little bit of Scotch-Brite and that'll be gone. But overall, the radius, super even though there's a bunch of cutouts and missing sections here on the fold. It's perfect. It's got a really nice even bend. Really chuffed with that. That's really good. Now that we've tried 70, 200, let's try something that's 600. Oh yes, you can see the whole thing's warping. Got a bit of deflection going on. Should we just push through? I think so. 600 wide. Really happy with how it performed. There's two things that I would adapt. That is reinforcing these end bits where you tighten down with a single nut. Ends up being too weak and a weak point, which allows this whole section to rotate, and that's why I wasn't able to bend the stainless, as well as a lack of a little bit of rigidity. The other thing you need to consider is your pivot point placement. Now I thought I had it nailed, but I actually haven't. If I was doing this again, I would mock this up in CAD. You really want your folding butt die to be pulling around with the bit of steel. That's just what's going to give you a nice curve without having wear marks. Now what mine does is it pushes against it nicely, and then the bottom edge, which was the leading edge, drops away and the top edge becomes the leading edge, and that's what leaves these wear marks. I know it only does that in the last 20 degrees or so, but that is often where the most force is required, and so you can see there's just a bunch of wear marks. Now I'm okay with that. It worked fantastic with the stainless I used, and it works fine with anything thinner like the 1.5, 1.2 mild steel. Works flawlessly. So yeah, really happy. Just a bit disappointed I wasn't able to get the 600mm wide stainless, but I think my hopes were pretty high in doing anything 2.5mm, especially stainless. Right, thanks for watching. I can't believe I got that much on my head.